Hello class. This is going to be a review of the answers. So I'm going to go over all the answers. So if you're not sure on certain questions, you can fast forward to those, or if you're struggling with the whole thing, then you can watch the entire video. But we won't have a lot of time in class to go over the test, so I am doing the review on this video so that you can get help ahead of time. So for the first problem, it says in the circle below, AD, so that's our diameter, is 10, and so if our diameter is 10, each of these pieces, which are the radii, are 5, and OE, so that's this little piece, is 3, and it says find the length of BC. So anytime you have these problems and you have segment lengths, you want to make a right triangle. So here's my 90-degree angle, and I'm going to redraw my radius between O and R, and call that 5 because that's the length of the radius. And now I have a right triangle, and I can use Pythagorean theorem to find BE. And then if I know BE, I can find BC by doubling it. So remember, C is across from the 90, so C is 5. So I'm going to do A squared plus B squared equals C squared. Then you're going to solve it. Don't forget to take the square root, so then x is 4. And then BC is going to be double that, so this is 8. And we know it's double because the right angle. Whenever there's a 90-degree angle, the chord is bisected. Okay, so number 2, in the circle below AD, again the diameter is 30, so I'm going to put 15 and 15 for the radii. And AC is 18, so this whole length is 18. Find OB. So it's the same idea. It's a little bit easier because they have the triangle. So I'm going to make this 9 because there's a right angle there. Call what I'm looking for x. And I'm going to do Pythagorean theorem again. And remember that your C is across from your 90. So your C is the 15. And then you're going to solve it. And then I get x to be 12, which is OB. Okay. Number 3 is a really easy problem if you remember the theorem. 2 chords that are the same distance away from the center, so since both of these are 4, are equal. Now 8 is only this piece, so this piece is also 8, and they have tick marks to show you that. So then x is going to be the length of the whole thing, which is 16. For number 4, the measure, find the measure of arc AB. So I want to find AB. And they said the length of AB, so if there's nothing on it, that means the length of the chord. So this whole thing is 20, and AO is 13. So again, we have a 90, so that makes this 10 because it's perpendicular. I want to find the length of the arc, so this is where we need to remember that the arc is equal to the central angle. So the measure of AB is equal to angle AOB. So if I find AOB, I can find the central angle. So I'm going to call X this little angle over by angle O, and I'm going to use trig to find that. So I have a right triangle. If I redraw it here, this is X. My hypotenuse is 13. 10 is my opposite because it's across. So O and H, if you write your SOHCAHTOA, is sine. So I'm going to do sine of x is equal to 10 over 13. Remember, you have to do the inverse, so the little -1 in your calculator. So you're going to do the inverse to find it. If you do that, you're going to get 50.3 if you round to the nearest tenth. And then remember, that's only this piece of O, so the other piece is equal. So to get the whole measure of the arc, we need the whole angle, which is times 2. So you get 100.6. And if you're not sure, we did a bunch of those on, I believe, day 2 or day 3. So look back and find that. Okay, so number 3. Now we're dealing with finding arcs when we have angles. Now remember, you always locate the point. The point is outside, so I'm going to use the outside formula, which is far minus near is equal to 2 times the angle. Okay. So before we do that, we need to make sure we have all our parts. Well, I don't know the near arc. They don't have anything. So when they have the far arc as x, you're going to call the near arc 360 minus x, because the whole circle is 360. So to find this piece, you would take 360 and subtract what's on it, which is x. And then when we do this formula, we're going to do far, which is x, minus near. You have to put it in parentheses because I'm subtracting the whole thing, is equal to 2 times the angle. Now you have to be careful about this because this is a -1 in front, so you have to distribute it. So you have to make it minus 360 and then plus x, because -1 times -x is plus x. And then we get equal to 84. Combine your like terms. And then if I come over here, I get 2x is equal to 444, and then x, if I divide by 2, is equal to 222. And then we're done, and we found the far arc. Okay, number 6 says find the measure of angle A, so I'm going to call that x. The measure of CD is 130, and the measure of CB is 80, and BC and DE are equal. Okay, so we're going to use the same formula we used up here, but again, we don't know the near. So to get the near, we need to take 360 and subtract everything that's on the circle. But unlike in number 5 where there's only 2 arcs, this has 3 different arcs. So we have to, or 4 different arcs, sorry, that's the 4th. We have to subtract all 3 from 360 to get the 4th. So we have to remember that because 2 chords are equal, the arcs are also equal. So ED is also 80. And then to get the near, I'm going to do 360 minus 130 minus 80 minus 80. I have to subtract everything on the circle. And if you do that, you get 70. So that's my near arc. And now we can use our formula. So I'm going to do 2 times x, because that's my angle, is equal to 130 minus 70. And then if you solve, you get x to be 30. Okay, number 7, it's very similar. Angle, here it is. It's outside the circle, so we're going to do the same formula. We have everything. Here's my far, x is my near, and 72 is my angle. So we're going to do 2 times the angle, which is 72, is equal to 212 minus x. Okay? And then we're going to solve it. So 144 is equal to 212 minus x. When you subtract, you get -68 equals -x, and then don't forget to divide by -1 or to change the sign. So x is 68. Okay, so number 8, now it's a little bit different. We're trying to find x. It's an arc on the circle. The angle that opens up to it is an inside angle. So we're going to use the inside angle. However, we don't know the angle that opens up directly to x, so we have to find it. So to get that angle, we have 43, and remember 43 and this missing angle are a linear pair, so they add up to 180. So to get this angle, I do 180 minus 43, and that gives me 137. Okay, so to get that angle, I did 180 minus 43, and that gives me 137. Okay, and that's my angle. So then from there, let me make it easier to see. Okay, then from there we can use our formula for inside. The formula for inside is 2 times the angle. So the angle that opens up to x is 137, is equal to arc 1 plus arc 2. Those are the 2 arcs that the angle creates, which is 89 and 137. Okay, and then you solve it, so you do 2 times 137, which is 274, is equal to, 89 plus, this should be x, sorry, the 137 up here, plus x. And then you're going to subtract 89, and you should get x is equal to 185. Okay. So if you're looking at Miss Brown's answer key, she's just off by 1. So make sure you fix that answer. Okay, so for number 9, we're finding x and y. Now this is probably one of the hardest ones. X and y, here's x, here's y. So what we have to do is figure out which one we can find first. So if you trace angle x, it opens up to this tiny arc, and then it opens up to this part of the circle, which is half a circle. So remember, half a circle is 180. And we can find this piece of the arc by doing, over here, 180 minus 55 minus 60, because again, I have half a circle here, which is 180. So if I do that, I get that arc to be 65. So this missing piece is 65. The other part that it's opening up to is 180. X is on the inside, so I'm going to do the inside formula again, which is 2 times the angle, which is x, is equal to 65 arc 1 plus 180 arc 2. It's the arcs that it opens up to. So then if you solve that, you get 122.5. So that's x. Now to find y, it is this arc, which is created by this outside angle. So we're going to use the outside formula. If you trace that, the far arc that it makes is this whole thing, which again is half a circle, so that's 180. So when we do this one, we're going to do 2 times the angle, which is 70, is equal to far, which is 180, minus near, which is y. And then we're going to solve that. And so we get 140 is equal to 180 minus y, subtract 180, and you get negative 40 equals negative y, and then remember we have to divide by negative 1 to make it positive. So y is equal to 40. Okay, so then we have number 10, and 10 looks a little bit different than what we've done before, but it's not. If you look at this, they said find the measure of x, y, and z. So if I take any of them, let's just start with x, and I trace x, okay, it's outside, and it makes 2 arcs on the circle. This one, which would be my near arc, and then these 2 arcs, which are my far arcs. And then we have to figure out the near arc. So remember, we have a circle. We know the 2 other arcs, so we're going to do 360 minus 130 minus 152, and that gives me 78. And then we're going to use our formula. So we're going to do 2 times the angle, which is x, is equal to, now the far is these 2 arcs together, because x goes to here, so that whole thing is the far. So if you add those together, you get 282 minus the near, which is 78. And then you're going to solve it, and you get x to be 102. And we're going to do the exact same thing for z and y. So to get y, I'm going to do 2 times y is equal to, okay, y goes to here, so the far arc is 152 and 78. So I'm going to add those together, and I get 230. So you do 230 minus 130. And then if you solve it, you get y to be 50. And then z, you could do the same thing, or you could also use a triangle that adds up to 180, which is a little faster, so I'm going to do that. So I'm going to do 102 plus 50 plus z is equal to 180, and then you can just solve that, and you get z to be 28. Yeah. So on z, I think Miss Brown forgot to divide by 2, so that's why it's 56, but it should be 28. Okay, so number 11, we need to find the length of the radius if AB is tangent to the circle. So we don't have the radius, so I'm going to call that r, and this is also a radius, so I'm going to call that r. And we're going to do Pythagorean theorem, and in this case, we're going to have our 2 r's. So when I do this one, this is our long one. So C draw your right angle in. The right angle is between the radius and the tangent. So my C is my r plus 9. So I'm going to do r squared plus 14 squared is equal to the whole side, which is r plus 9 squared. Remember we said you had to write that twice, and then you have to FOIL or distribute or do the box method, whichever way you're comfortable with. But you should get, when you do that, r squared plus 9r plus 9r plus 81, which turns into, if you add your like terms, r squared plus 18r plus 81. Okay, now if we solve, we're going to get the r squares on the same side, so they cancel. So I get 196 is equal to 18r plus 81. And then we're going to solve that, and we're going to get a decimal, and we're going to do 6.4 if we round to the nearest tenth. Okay, so then number 12, it says find the length of x if AB is tangent to circle O. Okay, so we need to find x, draw your 90 in, and then this piece again is 6. Now it's easier to call the whole hypotenuse C and find that because I have two sides, so I can do that. So I'm going to do 6 squared plus 8 squared is equal to C squared. Solve that, and you should get C to be 10 when you solve it. And then to get x, you're going to say x plus 6 is equal to 10, because 10 is the whole thing, and then x is equal to 4. If you make this 6 plus x like we did up here, you're going to have to factor, and it'll be hard to solve. So if you have two numbers for sides, you can call the third side C and then do Pythagorean theorem. Okay, so number 13, we need to find x, y, and z. So I'm going to start with z, just because I know what that opens up to. If I trace z, it opens up to a semicircle, which is 180. So then we're going to do 2 times z is equal to 180, and then z is equal to 90, or you do the arc divided by 2. To get x, I have to know y. So I'm going to find y by using, I have a semicircle on the top. So this is a semicircle. Again, it adds up to 180. So y plus 32 is equal to 180. So if you get that, y is 148. And then once you know that, zx is on the circle again. So you do 2 times x is equal to 148. And then if you get that, you get x to be 74. Okay, now there's a few different ways, so if you got the same answers, then that's fine if you did it a different way. Okay, so number 14, we need to find x, y, and z. So if I start, the only thing I know is 41, and z opens up to 41. So I'm going to start with z. It is on the circle, because the point is on the circle. So I'm going to do 2 times z is equal to 41. And then we're going to solve it, and you get z to be 20.5. Now, z and y are between the tangent and the radius. So z and y add up to 90, because the radius and a tangent are always perpendicular. So that's how we're going to find y. And then you get y to be 69.5. And then y is on the circle. So because it's on the circle and it opens up to x, to get x, we do 2 times 69.5, which is y, is equal to x. And then x is 139. Okay. And again, there was more than one way, so you could have also found the central angle, which is 41, because it's equal to the arc, and then do 180 minus 41, which is 139, and then that's the central angle that opens up to x, so they are equal. Okay, so then number 15, we need to find x, y, and z. So start with the arc, and if you trace the angle that opens up to it, y opens up to the arc, so 2 times y is equal to 35, so y is 17.5. Now if we want to help us, z is the same thing, 17.5, because it also opens up to 35. And then for x, there's two different ways. You could find this angle, which is 35 because it's a central angle, and then x plus 35 are a linear pair, so they add up to 180. So x is 145. You could also find the arc, which is 145 because we have a semicircle because this is my diameter. And then x is equal to 145. Okay, in number 16, in the circle below, angle A is 93. AC, so you always go the shortest way, so this way is 100. Find the measure angle C. So C is easy if you remember the formula. Angle C plus A add up to 180 because they're in a quadrilateral in a circle. So if you do that, x is 87, which is AC. And then to get arc AB, okay, so we just want this little piece. What we could do is we know each of these pieces are 50, and I can use the 93 because the 93 opens up to DCB, and it's on the circle. So if I do 93 times 2, that is equal to the arc, which is 186. And then to get this arc, I would do 186 minus 50, which gives me 136. And then to get this arc, I can subtract all the other arcs from 360. So I'm going to do 360 minus 50 minus 50 minus 136. And that gives me 124. Okay, so that should be the answer, 124. Okay, so for number 17, and just sorry, for number 16, for AC, Miss Brown went the other way, so that's why she got a different answer, but you should go the shortest distance, so it should be from ADC. Okay, so for 17, now we get into segments, so you have to know your formulas. So this is two chords that intersect, so when you do that, it's piece times piece equals piece times piece. So you're going to do 15 times x is equal to 10 times 6, and then you're going to solve it, and you get x to be 5. For 18, we want to find the radius, but in order to know the radius for this one, I have to know the diameter. So again, it's two chords, so I'm going to do 5x is equal to 10 times 10. So 5x is equal to 100, and then if you solve that, x is 20. Okay, to get the diameter, you add x and 5, so you get 25, and then the radius is half the diameter, so it's 12.5. Okay, so for number 19, we're going to find the value of y. So for this one, we have two secants. So for two secants, we're going to do the outside times the whole is equal to the outside times the whole. So for this top secant, the outside is 4 because it's outside the circle, and then I'm going to do 4 plus 21. To get the whole, we add the two pieces, and then I'm going to set it equal to the outside, which is y, and then the whole thing, which is y plus 15. So then when we do this, you're going to add 4 plus 21, which is 25, times 4, which is 100, is equal to, and then you distribute, and you get y squared plus 15y. Now, because there's a y squared and a y, this is one where you have to get everything to one side and factor or use your calculator. So remember to use your calculator. You plot it in y1, so you go to menu and graph if you have a Casio, and you're going to type in y squared plus 15y minus 100. However, you're going to use x instead of y for it. So you should type in x squared minus 15x minus 100. If you have a TI, you just hit y equals, which is in the top left of your graph. You're going to draw it. If you have a Casio, you're going to hit shift G solve, and then you have to hit root, and you need to make sure you have the positive one. And if you have a TI, you have to hit second calc and then 0, and then you have to go to the left side of it and hit enter, to the right side of it and hit enter, and then hit enter again, and it should give you. If you're not sure about that, you can come see me in the morning one day and I can show you how to do that. The other thing is you can just factor it. So if you don't have a graphing calculator, or if you don't remember how to do that, to factor you do 2 sets of parentheses because we're doing FOIL backwards. For the first, you figure out what multiplies to y squared, so that would be y times y. To get the last numbers, you figure out what multiplies to negative 100 and adds to the middle term, which is a positive 15. So that would be, if you do your factors, it would be 20 and negative 5. Okay, and you need the 20 to be positive because when you do 20 plus negative 5, that gives you a positive 15. So you put plus 20 because that's one factor, and then minus 5 because that's the other. You set each one equal to 0. Because if one of them is equal to 0, then the whole thing is, and then you solve. So y is equal to negative 20, and y is equal to 5, and you cross out the negative one. And that would be your answer. Y is equal to 5. Okay, so number 20, this one we're trying to find x. X is a tangent, and then 9 and 11 make a secant. So when you do this one, you do x times itself, which is x, or x squared, is equal to, and then again the secant, you do outside times the whole. 9 plus 11 is 20, and then you're going to do 20 times 9, which is 180. To get rid of a square or squared, you take the square root. And then the square root of 180 is 13.4. Okay. Number 21, you want to find the perimeter of the pentagon. All right, so remember, to find the perimeter, we need all the missing pieces. So I need the 3 pieces that I am outlining. All right, so to find this piece, I have to know the piece next to it, which means I have to work my way around until I find a piece that I know. So I know that this is a 2. And remember, if it's tangent to a circle and meets at a point, they're equal. So this is also 2. That makes this 3, because 5 minus 2 is 3. So this is 3, and then 8 minus 3 is 5, and then this is 5. Now this piece here is equal to the one next to it here, and then this top piece here is equal to the next one here. Since I don't know either of the pieces, I can make them anything as long as they add up to 7. So I'm just going to do 3 and 4. You can do 2 and 5, 6 and 1, any of them. And that would make this 3 and then this 4. And then when you do perimeter, I'm going to add all the sides. So I'm going to use 7 for this whole side, plus the other side is 3 plus 2, plus I'm going to use the whole side because I know it, 5. Plus the whole side, which is 8, plus the next side, which is 4 plus 5. And then you're going to add them all together to get the perimeter. And if you do that, we should get 34. Okay, so then 22 is just definitions. So define the following or give the formula. So a chord, remember a chord has its 2 endpoints on the circle. I'm not going to write them, I'm just going to say them. So you can pause if you need to and then rewind if you didn't get it. A tangent intersects a circle at one point. And the diameter has its endpoints on the circle but goes through the center. Okay, number 23, we want to find the measure of DA. Okay, so DA makes a half a semicircle with AE. And remember, a semicircle is 180. So to get DA, I'm going to do 180 minus 125. And that is equal to 55. So DA is 55. Angle AEC, arc AEC. So when you do that, remember, you start at A, you have to hit E next, so I'm going to go down and then up to C. So for that, I got to figure out this angle. Okay, so to figure out that angle, this angle is 55 because we just found out that this arc is 55 and they're equal. And then the tick marks mean they're congruent. So this is also 55 and this also would be 55 because these are vertical. So then to get AEC, I'm going to add the 3 angles that make it. So I'm going to add 25, 55, and 55. And that gives me 235. Okay, DC is this little arc here. And I can use the other 2 angles or arcs that I have, which are both 55, and I have a semicircle up top. So to get this, I'm going to do 180 minus 55 minus 55. And that gives me 70. And then CAE, so I'm going to do CAE. So I'm going to erase all my marks to help us figure out where CAE is. Okay, so C, then I'm going to hit A to E. Okay, remember this is 55, this is 70. So I'm going to do again 125, 55, and 70 to find it. And that gives me 250. And then the rest is the old stuff, so I'm actually not going to go over it just to make this video a little bit shorter. So that we should know because we've been doing that since the beginning of the year. So there will be a distance midpoint slope on this section, so make sure you study it. And if you have any problem, come see me in the morning. Okay? Bye.